Look at your phone screen right now. It's glowing because tiny particles of light are hitting your eyes. You'd think of light as simple, a beam, a glow, a thing that travels from here to there. But for over 200 years, light has been hiding a secret, and when scientists finally caught it, the secret broke physics. Richard Feynman, one of the greatest minds who ever lived, said this single experiment contains the only true mystery of the universe. He said you can never explain it away. Most people think they understand light, but what's about to happen will sound impossible. And the strangest part isn't the result. The strangest part is that the universe seems to change its behavior depending on whether you're watching. Let's start simple. Imagine throwing tennis balls at a wall. In the wall, you cut two narrow slits. Some balls go through the left slit. Some balls go through the right slit. Behind the wall, you get two stripes, two piles of balls lined up behind the two openings. That's what particles do. Two slits, two stripes, simple. Now let's try it with water. Drop a stone in a pond and waves spread out in rings. Send those waves at the same two slits. Now something different happens. The wave splits and passes through both slits at once. On the other side, the two waves crash into each other. Where two peaks meet, they grow taller. Where a peak meets a trough, they cancel out. This creates a pattern of many stripes, not two. Bright, dark, fading out across the wall. Scientists call this an interference pattern. It's the signature of a wave. Many stripes. So now we have a clean test. Particles make two stripes. Waves make many stripes. So which one is light? In 1801, a man named Thomas Young ran exactly this experiment. He shined light through two narrow slits, and on the wall behind he saw many stripes, the interference pattern. Light was a wave. Case closed. For 100 years, that was the answer. But here's where it gets strange. Light isn't a smooth wave at all. In the early 1900s, physicists discovered light comes in tiny packets. Single particles of light called photons. You can fire them one at a time. So scientists asked a haunting question. What if we send the photons through one by one? A single photon alone, with nobody to interfere with. It has to go through one slit or the other. It should just make a single dot on the wall. Fire enough of them, one at a time, and you'd expect two stripes. So they did it. They fired single photons, one after another, for hours. Each one landed as a single dot, a particle. But as the dots piled up, a pattern appeared. Not two stripes, many stripes. The interference pattern came back. Stop and think about what this means. Each photon was sent alone. There was nothing else for it to interfere with. So what did it interfere with? The only possible answer is almost too strange to say. Each single photon went through both slits at once. It interfered with itself. A single particle splitting into a wave of possibilities, passing through two openings and recombining. This is not a trick, this is the real result. Now the scientists did the obvious thing. They decided to watch. They placed a tiny detector at the slits, just to see which slit each photon actually goes through. A simple measurement, a camera basically. And the moment they turned the detector on, everything changed. The photons stopped going through both slits. Each one now picked a side, left or right, and on the wall, the many stripes vanished. Two stripes appeared instead. The light started behaving like ordinary particles. Read that again. When nobody looked, light went through both slits and made a wave pattern. When they watched, it went through one slit and made a particle pattern. The act of looking changed the result. The universe behaved differently because it was being observed. Then they tried something even more unsettling. They turned the detector off again. Instantly, the wave pattern returned. They could switch the behavior of light on and off just by choosing to watch or not. Physicists have repeated this experiment for over a century. With light, with electrons, with whole molecules, the result never changes. Unobserved, the particle behaves like a wave of possibilities. Observed, it collapses into one definite reality. Nobody fully agrees on what this means. Some say the particle exists in all states until measured. Some say observation forces the universe to choose. Some say there are parallel worlds where every outcome happens, but every explanation is stranger than the last. And here's the part that should keep you up at night. You are made of these same particles. Every atom in your body follows these same rules. The hand holding your phone is built from things that don't fully decide where they are until something interacts with them. Reality at its smallest level isn't solid. It's a fog of possibilities that sharpens into something real only when it's measured. So look at your screen again. That light hitting your eyes was a wave and a particle, both at once until it arrived. The simplest thing in the world, and underneath it, the deepest mystery we've ever found. We still can't explain it, we can only watch it happen, and the universe, it seems, knows when we're watching.